So in the last episodes, you have learned about one-to-one and many-to-one function, and now we shall learn about one more type of function which is called as on-to function or surjection. Now a function f from set A to set B is called as on-to function or surjection if every element of set B is the f image of some element in set A. So like in the diagram you can see all elements of set B, P, Q and R, they are the image of some element in set A. Or we can say every element of set B is associated to some element in set A. Or we can say a function f from set A to B will be an onto function or surjection if and only for every element in set B there must be some element A in set A where value of f is equal to B. Also, you will note that in case of an onto function, the range of the function is equal to the codomain of the function. Now again check from the diagram whether these functions are onto function or not. In the first case, you can see in set P we have got three elements P, Q and R. And you can see all elements are associated to some element in set B. So as per the definition of onto function, this is an onto function. In the second case, here P and R are associated to set A, but Q is not linked to any element in set A. So that means this is not an onto function. So this is not a case of surjection. In the third case, P, Q and S have some image in set A, but the element R has got no pre-image in set A. So is this an onto function? No. As per the definition of onto function, every element of set B must have some pre-image in set A. So this is not an onto function. In the last case, you can see all elements of set P have some pre-image in set A. So this is an onto function. So in this diagram, function 1 and function 4 are onto function. Now let's solve some question. Suppose we have a set A which contains 4 elements 2, 4, minus 2, minus 4 and set B which contains 4 and 16, and we have a function f from set A to set B which is defined as f of x is equal to x square. Now is this an onto function? Now let's find the value of this function for all values of set A. Now f of 2 is equal to 2 square, that is 4, and f of 4 is equal to 4 square, that is 16. F of minus 2 is equal to minus 2 square, 4, again it is equal to 4, and f of minus 4 is equal to minus 4 square, that is 16. Now here you can see the element in set B which are 4 and 16. Now 4 is the image of 2 and minus 2. Similarly, 16 is the image of 4 and minus 4. So that means all elements of set B have got at least one pre-image in set A. So as per the definition of onto function, the given function f of x is an onto function. Now let's solve one more question. Now here A contains 3 elements 2, 4 and 5, and B contains 4 elements 8, 27, 64 and 125. And the function f from set A to set B, which is defined as f of x is equal to x cube. Now is this an onto function? Let's again find the value of function for all values of x. Here f2 is equal to 2 cube 8, f4 is equal to 4 cube or 64, and f of 5 is equal to 5 cube, which is equal to 125. Now here you can see in the given function, now 8 is linked to 2, 5 to 125 and 4 is associated to 64, but 27 is not linked to any number. So that means the given function is not an onto function. And now I will discuss the algorithm to test whether the given real function is an onto function or not. Now a given real function can be tested for surjectivity by following 4 steps. In the first step, we take any value y from set P, and in step 2, we put f of x is equal to y. And in the third step, we solve the equation f of x is equal to y, and then we find the value of x in terms of y and write a new function x equal to g of y. And in the final step, we check if for all values of y from set B, the value of x which we get from x is equal to g of y are in set A or not. And if the values are from set A, then it is an onto function. But if there are some values in set B for which x, and remember x is equal to g of y, is not from A, then this is not an onto function. Now let's try to understand this algorithm with the help of an example. Check whether the following function is an onto function or not. A function is defined as the function f from set R to set R, where f of x is equal to 2x cube plus 1 for all x which belongs to real numbers. Now suppose y belongs to real number and f of x is equal to y, or we can write y is equal to 2x cube plus 1, or we can write 2x cube is equal to y minus 1, or we can write x is equal to cube root of half of y minus 1. And remember, step 4 says that this value, the cube root of half of y minus 1, must belong to set A, and the set A is a set of real numbers. And now, since the cube root of half of y minus 1 belongs to a real number, so that means the given function f of x is an onto function.